Hi, I'm Chris Jennis. I'm a data scientist at Distillery. At Distillery, we use machine learning to build targeted audiences for online advertising. And here I'm going to talk about how we use machine learning to predict in-store visitation. So if we could predict who would show up at a specific store, we could do a number of things. For instance, we could understand the behaviors of visitors to that store. Important for Distillery, we could target those likely visitors with online advertising. And then you could also do various things like plan future store opening locations. But first, I'm going to take a step back and talk about how we build these predictive in-store visitation models and talk about specifically the data that we use. So each person has a laptop, a cell phone, maybe a tablet. Important for this talk, on the laptop, we see the list of websites they've been to and the days that they went there. And we get similar information for their tablet. On people's phones, we also see their website visitation data, but they take their phones around with them in the real world. And so their cell phone will show up at places like Best Buy, a Subaru dealership, and McDonald's. And when we see the cell phone show up there, we know that the person likely showed up there. And so you can see where this is going. We want to predict these in-store visitations on the right using their website visitation data on the left. Okay, but first we need to tie all their devices together. And to do this, we use an algorithm based on IP frequencies. So when a person uses all of their devices frequently in their home, we know that they likely all belong to one person or one family, and we'll link them together. And then we also have a number of data cleansing steps. Specifically here for this talk, I'm just focusing on a few examples of how we filter out bad geo data, so the data that says they were at McDonald's or not. So the geo data comes to us in the form of raw lat longs, which then we assign to locations. And we look at the distribution of raw lat longs that are sent to us, and we'll filter out commonly seen lat longs. So for instance, the top example I'm showing, this is the most common lat long that's sent to us. This is the center of the United States, which is obviously an error. And so we'll filter out this common lat long and other ones like this. Secondly, lat longs can be sent to us with low precision. So if there's only 3 digits after the decimal place, for instance, we only know where that device is to within 100 meters. And so if this is the case, we don't know if a device is at McDonald's or just across the street from McDonald's. And then this last example I'm giving is more anecdotal, but some cell phones send us data where the raw lat longs are snapped to a grid. And again, you can imagine here, this is hard to say if a person is at McDonald's, or maybe they're across the street, and then it was snapped to a grid that put them at McDonald's. And so we'll filter out these instances of low quality lat longs and then only use high quality data to assign devices to locations. Okay, so once we have the data collected, linked together, and then cleaned, this is our strategy for building our models to predict who will show up at a store. So we build 800 separate logistic regression models, one for each store of interest. So for instance, we'll build one model for who will show up at Target, one for who will show up at Home Depot, NFL stadiums, et cetera. And as I alluded to before, the features of our model are which websites that person has visited. So MLB.com, ESPN.com. And then the labels for our model is, did they show up there on their mobile device? Okay, and this is the general strategy we'll use. And this strategy works quite well. So across our 800 models, the median AUC is 63.9. And if you look at models sort of around that median, so NFL stadiums, predicting who will show up there, the AUC is 65.1. And I'm giving some examples of basically the top features that are predicted that you'll show up at an NFL stadium that the model gives. So things like if you go to CBSSports.com or the Sports Illustrated website, that's predicted that you'll show up in an NFL stadium, which sort of makes sense. Home Depot, similarly, this AUC is around the median. And what's predicted that people will show up at Home Depot are basically doing things like you would expect. So going to SherwinWilliams.com, DeWalt.com, that's a power tool company's website. And if we look across our models, we basically see the same trend. Okay, and then just to tie it back to the original goals, usually what we use these for is for basically targeted online advertising. So targeting people that are likely to show up at Home Depot with ads. But what I'm showing here is, like I said, we could also understand how the behaviors of visitors to Home Depot. So what I did, if you focus on the top, I took the model that predicts who will show up at Home Depot, and I scored our entire universe against this model, and then took the top 1% of the people that scored into it and said those are the people that are most likely to go to Home Depot. And then we have a number of other attributes that we know about those people independently from the model. And so if you look at what those people that are likely to show up at Home Depot look like, it's basically like you would expect. They're 23 times more likely to be power tool shoppers than a random person. They're more likely to be country home decorators, DIYers, et cetera. And then if you look at their age distribution, they basically span all age ranges except the youngest. And then alternatively, you can imagine the people who are likely to show up at NFL stadiums are slightly more different. But it's again as you would expect. So there are also college football fans, fans of other sports, fans of other sports teams. And then again, their age distribution kind of skews a bit younger, which is kind of what I would expect of what people would show up at NFL stadiums. All right, so thank you. I'm Chris. If you have any questions, you can find me later.